Hey everybody, how's it going? Glad to have you with us this evening. It is Houdini Hangout. It's the 6th of July, and tonight we're going to be playing around with um, some particle effects, doing some 2D pyro slash smoke sims, and yeah, just kind of playing around with that and getting something. Um, Hopefully working, from all of that. I think we've got a cool setup going that I have played around with a little bit ahead of time. If you aren't on the Discord channel, please feel free to go to houdinihangout.com, and there's an invite link on there for you to join our Discord server. And yeah, you can in that there's places for you to be able to put um, an idea maybe for a stream or some sort of something maybe you've seen before that you're like, hey, this seems like a cool thing to be able to learn how to do. Can't promise I'll be able to do everything or anything, like, be able to do every single thing that gets in there, but, or even know how to do them. But, just it's a good place for us to be able to talk and learn. I've also kind of set up a couple different places in there, like if you're running into any problems or anything like that, there's a little help channel in there that we can kind of all speak into and kind of talk there, and just general chat stuff. And if you wanted to go there to chat through Discord on the stream, that'll work as well. So, just a few different ways and things that you can do on there. So, also on the website, there's links to both YouTube and Twitch, depending on if you want to get connected to either of those places and you maybe found this from one or the other and you'd prefer to use, the other stream. The links are there as well. And yeah, so let's kind of jump in a little bit here and take a look at kind of what we're going to be creating. So I'll show you a real quick, maybe a quick render here of what we're looking for. Let me pull one up here. Let's see. Yep. So this is kind of the idea of what I'm going to be going for. Now the movement is all driven by a smoke simulation, and the um, the kind of the objects on top of it are all put there from a copy to points, and using a particle sim to kind of push and advect these points around. So obviously we could do more just than that, but this is kind of where we'll start, and we'll see kind of where we get by the end of the stream. So all right, so the first thing I am going to do is I'm going to set up some geometry here that we'll be able to use for our sim geometry. So I'm going to call this sim source, and get some color in here. Cool. So I'm just going to start with a grid. Put that down. Sorry, somebody's texting me right now, and I'm going to put that on silent. Cool. All right, so we're going to use this grid to kind of start off and create our geometry that we're going to source our smoke from, basically. So I guess we can just start out with a regular size grid. Let's do this at like 250 maybe to begin with. We can always go up from there. But for right now, I think that'll be good. I'm just kind of checking. I have just looking at what I've done before over here, just so that that I'm not just like pulling these numbers magically out of the air. I did kind of play with this before, but I'll explain some of the reasoning why we're going through some of these things. So next, let's just do a pyro source. So what we can do with the pyro source is we can either keep our input, which is going to keep these points. You can see those are all now individual points instead of a grid of of polygons. So we could also do something like scatter on the surface, but this is going to give us an irregular pattern. And I'm really thinking that we want to start with something that's a little bit more regular because we're going to be doing a two-dimensional, smoke solver basically. So, sorry, I'm just noticing that I got a new camera not too long ago, and I'm just going to turn off the white balance adjusting because it's like as I put my hands up here, it's like freaking out there. So I'm just gonna dial this in real quick, make sure I don't look too crazy here. Let's see, where are we? My apologies. I just want to make sure this isn't going crazy the whole time. Cool. All right. So instead of doing this kind of irregular grid, let's just keep it the way it was here. So that's going to take those points, and I'm going to initialize, I think just smoke. Yeah, that should be all we're going to need. And what that's basically doing is just using point attributes to create density and temperature values here. We can see right there that our default values for density and temperature are both at 1. So that should be good. I don't think we have to worry too much about that. And yeah, so particle separation, it isn't going to be determined by this here, because if we use something like surface scatter and tweaked this, that's going to change our particle separation and adjust the p scale as well. Here we want to keep the input, and it's saying it's 0.2 for the p scale. I'm not sure if that's actually correct. Let me just double check if this changes. If we were to do this, I don't think it will. So I think that's just the default. Yep, correct. Okay, just making sure that that's not actually calculating that, because that would be cool if it did. So what we could do is we could take the size here and divide it by one of these rows or columns, because we know we're going to keep them square. So what we could do there is we could take, I'm just going to copy this parameter, paste it over here, and obviously that's getting crazy big now. And then we can take this parameter. Doesn't really matter since they'll always be equal. And we can do divided by and then paste relative reference there. And that should give us our p scale, or our particle separation of 0.04. And the particle scale is just basically saying it's double that. So we can see here the p scale is 0.08. And if we're rasterizing that from that, we should be good to be able to just that should cover our whole surface basically. So let's do a volume. Oops, gotta hit tab. That's what I gotta do. Let's do a volume rasterize attributes, and we're going to rasterize up here. We're going to take density and temperature. We can see that we're starting to get this volume set up here. What we are going to want to do, I believe, is adjust this voxel size so it's matching with this, I believe. So let's just copy the parameter there, and we can paste the relative references there. And the particle scale is going to be 2, I want to say. Yeah, I think. Should be right, because our particle scale here is 2. And so now we should have our volumetric grid, and that's pretty much exactly the same size. It's maybe just slightly off because we're talking about 250 versus 260, but let's see if we set this back to 1, if that's closer to what we actually want. Yeah, I guess we could keep the particle scale at 1. So we've got this nice thin volume, but we're only going to be taking a 1D slice of it. Right now this is 5 high, but that's just because of the particle size. So what we're actually going to do is just slice this two-dimensionally. The other thing, though, that we want to kind of do here is not just take a flat volume for this whole thing. We want to actually add some noise in there. So let's do attribute noise. We're doing attribute noise float. And And the reason that I want to do this is because, instead of doing something that would be let's say like the attribute adjust or something like that, is that we can actually have this operate on multiple attributes at the same time, or at least we should be able to. We'll take a look at that in a second. But so what we're going to use here is we're going to do density, temperature type, temperature. Cool. And we can see right here that these are both getting randomized. Now we're getting random values there. What I want to do is just have this be set, and we're going to do, let's do minimum maximum, and we can just do it 0 to 1. And then when we look here, we should be getting some sort of a, yep, we can see we're getting like a gradation of our attributes there. And if we normalize this by clamped coverage, that should be right as well. Cool. So now we're rasterizing both the density and temperature. We've turned those into volumes, VDBs to be exact. And so we have those set in here. So that's good. That's exactly what we want. I'm going to put a null down. And let's do this. And the reason that I'm adding some noise in here is because I want this to kind of have some variation, as we're talking about, say, temperature and density. I want that to be able to kind of flow and move differently, like as it's getting, pushed around in the scene. It's kind of has the ability to push, not just have the velocity just push this uniform volume around, but have a velocity that's also being affected by changes in the temperature in the simulation and changes in the density in the simulation. So, cool. So we've got that. Let's just say out here. And I'm going to change the scale of this a little bit, the attribute noise. So let's take our element size and turn this maybe down a little bit. Actually, no, maybe go up with it a little bit so it's a little bit bigger. I don't want it to be super tiny. And let's look at the fractal as well. Now, there's going to be more detail in this when we, if we up the resolution of this grid. So, for example, if we did something like crazy, like 1,000, we're going to see a much higher resolution of this noise in this grid. And in fact, what we could see here as well is if we go to the attribute noise float here and just turn on something like density, we can actually see these attributes here. And so what I'm going to do is I'm going to right click on this. I'm going to change this and not have it be auto. I want to do a min and max. And I'm going to change this because I find that to be a little hard to see because it's going through white and we're on dark here. So this will be a little easier to see. Cool. So here we can see the size a little bit better. And so, yeah, so we can adjust all of these different attributes here. So we could make it more rough. We can change it to be smoother and have less octaves. We can have more octaves, things like that. So, yeah, I think that's looking pretty good. Let me just double check what I used previously here. Yep. Cool. All right. So that's looking pretty good. And the other thing that I'm going to do is, that's right, I'm going to use a little bit of a remap here. And what this is going to allow us to do is kind of push these values a little bit more towards the high and the low, basically. So what I'm going to do is I am going to select shift click both of these, and I'm just going to do, I guess I'll just do the monochrome cubic. There we go. And then what I can do with this is just kind of give us a little bit more of the dark areas. And then over here, I can get a little bit more of just these like solid areas as well. So this is kind of this solid, all the way dense areas. And this is the zero density areas. So you can see we've got a little bit more, change going on there basically between these different levels. And yeah, so let's see here. So we can kind of just tweak this as we want. Sure. Let's start something in there right now just to get a little bit of variation. We've got that coming out, so that should be good. This has, again, both density and temperature. So yeah, we should be good. Oh, I'm going to turn this back down so we don't have to do the huge, well, let me turn it to like that. There we go. Now we don't have to do the huge simulation. If we look at this, we can see obviously we have a lot less points as well. The noise pattern is going to be relatively the same, but the way that it can be written into the volume is going to be considerably different. So, all right, so we got this. Let's come back up here and we're going to do another geometry node. Actually, no, I'm going to do a DOP network because we're just going to be doing a DOP network in here. And we'll say sim pyro. And let's jump in there. So we're going to need a no. Forget if there's a pyro object or just a smoke object. I think there's just a smoke object. Yep. Let's do the pyro solver. I think I did this before with just the oops, with just a smoke solver, and I'm kind of curious if this will be any different. So let's give it a shot. So what we're going to do is we're going to set this smoke object here. So we'll say 2D smoke. Maybe we'll name this. Oh, what? Didn't like that. Okay, whatever. I thought that'd be fine. Guess didn't like that. All right. That's why. So what's the difference between the sparse and the regular solver? Okay, so the sparse solver is a little bit different because what it actually does is activates the volumes differently than the traditional pyro solver does. So in a traditional pyro solver, it has to kind of it has to solve the entire domain kind of this pyro source. But in a sparse solver, it can see it basically, you give it rules to activate regions of your simulation so that it doesn't have to calculate the entire bounds, three-dimensional bounds of your object. And so what that does for you is they're a really cool example they did when they launched that version that had it. Maybe it was 18. I don't remember what version first had the sparse solver, but they showed a rocket launch and they had it go up and kind of arc over. And if you think about it, if you were starting a simulation here and having it arc and come to the other side, normally what it would do is have to expand your simulation to completely bound that area so that it can solve all of that. But there's a lot of negative space in there that it doesn't have to solve. And so what the sparse solver can do is actually kind of deactivate those parts and not have to calculate those at all. So basically sparse meaning that there's deactivated parts of the volume versus a regular solver that has to work on everything. Now, a GPU solve, I don't believe, as of right now, can't do a sparse solve. So if you want to use your GPU versus your CPU, like say a kind of a weaker CPU and a really killer GPU setup, you kind of can't use the sparse one because GPU needs to be loading those volumetric fields all as one big block and it can't deactivate them and stuff. So there's different rules for each of those and how those work. But yeah, that's basically the difference between the two. And in fact, now that I'm noticing this, I actually have to turn off the sparse solving, so there's really no reason to do that. So I'm just going to do, it's like my tab isn't working. It's really weird. Smoke, I can type smoke object. So we're just going to do that. And then we'll do a pyro solver. So we'll just do the normal one. This is, I think they actually consider this to be the legacy one now, but I mean, it's fine. It's not really a big deal. And we're going to be doing this two-dimensional anyway, so we have to turn it off. So when we do this two-dimensional, it's going to go insanely fast. So, okay, so we've got our two-dimensional plane. The division method is going to be by size, and we've got these here. So let's grab some we know that the size is going to be 10 by 10, so that's easy, and we just want it to be, well, it doesn't really matter because it's just going to be a two-dimensional slice, so one is fine. The center is good, and let's copy and paste that this voxel size here. So let's copy that parameter, bring it over here, paste relative references, and now we should have our voxel grid set the same in here. Cool. So we have our pyro solver here, and this is actually solving right now. Doesn't probably look like it, but it is. Let's see what happens here. Yep, nothing. Nothing is really happening. So yeah, there's not really a lot that's happening. We can turn off this combustion. I don't think we really need to worry too much about that. And let's see, can we actually get this to, I'm not sure if this will actually dissipate or not. No, it doesn't look like it wants to. It's interesting. What if those don't work on a two-dimensional thing like that? Let's make sure the boundaries are closed. We don't want it to be escaping. And let's come up here. Let me see if I add the turbulence in, if that'll do anything in this. No, actually don't think it's going to. Yeah. Yep, it doesn't look like it wants to because it's a two-dimensional grid, so I'm guessing that some of these things really aren't going to do too much for that. So let's instead now we're gonna do some of our own stuff here. So I just want to kind of just remind myself what I'm doing here because it's a couple days. Here. Yep. So what we're gonna do is we're gonna do a gas field VOP. And one of the things I know we were talking about on Discord was, or maybe on a previous stream, was how to know where things go in this chain. And you can get a little bit of a hint here from these colorings. Those are actually kind of specific. So if you look here, I'm just going to disconnect this. Oh, and I'll hide this as well. Oh, I wonder if I just wasn't seeing that diffusing. It might have actually been diffusing. That's kind of funny. Oh, I didn't point it to the initial data. That's why. It's working, but okay. Sorry. Not thinking straight here. All right, so what I'm going to do is actually come up here. I forgot one thing. I'm going to take this and I'm going to say density out. Got to point it to this stuff first. And I'm going to split these just to give it two different locations to copy from. So this will be our density on this side. And then on this side will be our temperature out. Actually, I could probably just do temp. Cool. All right, so that's going to now put those, and we need to source these into here. So it probably should be working. It just, I was being a dummy and had it viewing the other stuff. All right, so there's our density. Let's bring in our temperature. Here's our temperature. Great. And that should be good. Yep. Actually, you know, we don't need all of these different things. Like we won't need heat. We'll need burn. We'll need fuel. Save us a little bit of time in solving. Okay, so now I'm guessing that this is actually going to do something here. So let me turn this dissipation back on. Yeah, there it is. Okay, I was gonna say it's got to do something. So we're dissipating here all of our smoke. We don't want that to happen. We want it to kind of stay together so that we're not. So we're gonna turn that off. Great. Good. The other thing I want to do is probably don't want to diffuse the well, we'll see. We'll try this temperature or turbulence here. I'm just going to turn that down a little bit. Now we should start to actually get some swirls and things moving around, which is cool. I mean, that's great. But I think what I'm going to do is instead of that and just kind of letting it, you can see how quick this is. Obviously, it's very quick to solve because it's just a grid of it's just a two-dimensional grid of voxels, so it's very quick to solve. The only thing here is we don't really maybe have some of the things that I would kind of hope for in this, and I want to maybe add some velocity in here as well. So I'm going to turn this off for right now, but we can always turn up some of these things as well. So, we can play around with this in a little bit and see what we get. So so what I was saying here is that as we turn this off, and we can kind of get some idea here of what these are used for. You can see that this is purple. These are purple. You can see that this is white, or kind of gray. This is a gray input. So it's not going to want me to put this into here. It's going to freak out. That wants to go in there. And this could technically go into any of these or multiple of them. And it's really just where it is in the stage of your solver. So you can see here, this is the pre-solve step, and this is the post-solve step. So here it's saying solvers go in here, sources go in here, and maybe anything you want to happen before a solve goes at the very beginning. So, so let's pull this maybe in here, maybe velocity update will be good. All right, so this is a VOP, so we're going to go inside. And what we're going to do is update the velocity. So I'm going to just do a bind export and say this should be vel. And this is going to be a vector. Oops, not a normal vector. And I'm going to just cut those. And what we want is also a bind in. And that also is going to be vel. And that's also, oh, that's going to be set from the other one. It's angry at me. Excuse me, sir. What are you doing here? It's not very happy at me. Oh, that's weird. It's just like the interface got stuck. Huh, weird. So basically this is just going to be in and out, right? So did it really? Are you doing this a lot? Oh, that's so funny. Yeah, it's so probably I should have bound it in first and then had it export, but whatever. Because what usually it does when you have two things in here like this is it's actually going to be pulling, it's going to be kind of pulling these attributes from each other, and this one here is setting the parameter attributes, so they're the same. So this one's the one that's setting the attributes. So I think when I had this and I started to, I typed it in and clicked that next thing, and it was like, trying to freak out. Anyways, so these basically are just, this is your previous velocity that's coming in, and this will be what it writes to disk, or to the sim. So I'm going to do I think it was a curl noise that I used that worked the best. I tried it with a bunch of different noises, and you can always do these with, oh no, sorry, not a curl noise. Anti-alias flow noise was actually what I liked. And because you can try this with a bunch of different noises, and you can get different results. So what we're going to do here is we're going to put P into the position. I'm going to put the offset. I'm going to put the time into the offset. And then what we can do is we can mix in this noise into our velocity. So the one thing we want to do is we don't want to be setting any y axes of velocity. So let's set this here. So we're getting a 3D output. You can tell it's 3D because of the difference in color, position, frequency, offset. Those are all vectors. Amplitude, roughness, floats, and then max octave is an integer. So the different colors tell you that. So we want to add this noise, or actually I want to mix it in. So I'm going to use the mix node, which can be used for color as well, but you can also use this to bias two different vectors. And so what I'm going to do is bring this in, bring this in. But what I want to do here first is I want to make sure that we're not getting any y-axis stuff happening. So I think what we can do, I did this differently before, but let's see if we can do set vector component. I believe this is a vector in and out. Sure is. So here's what we're going to do, vector component in and out, and I'm going to set component 2 to be this float value here, and this should just be 0 basically. So this should make sure that our velocities are always 0 up in the vertical axis and our y-axis. So what we can do now with this bias is we can bias it more towards the first input, which is in this going to be all the noise, or we can bias it more towards the previous velocity that was coming in and just add in a little bit of the noise. So this is kind of like a blending between the two. So it's kind of a nice thing. You can kind of help art direct it a little bit in that sense. So let's play this and see what happens here. I don't have anything else enabled. I'm going to turn these all way down as well. Let's just do this at 1, and let's do this at, I don't know. I'm just kind of guessing right now. Also, we don't need any buoyancy. Cool. All right, so let's see what happens here. So we're starting to get some swirls and things like that here. And this should be offsetting using the time. So, yep. So there we go. Let me hit the little clock here so that we get it playing back in real time. And this is just looking maybe a little too wiggly. It's not really pushing it around the way I'd like for it to. So let's go back into here and let's change the amplitude of this. Or actually, first of all, let's change this back so we're biased maybe a little bit towards the middle. And now we should have more of the noise pattern going here, right? And if we go all the way this way, we're going to be looking at basically just the noise. There's not going to be any like continuing velocity that's getting kind of pushed through here. We could average these together, but you aren't getting this same kind of mixing ability to kind of control here. So let's up the amplitude a little bit, maybe to 5. Yep, that's going to really push it around. Start to kind of smush that around. So let's turn this down. Maybe we'll do it to like, I don't know, 0.75. So it's going to be mostly that. Cool. Starting to get something there. But I feel like the noise is moving too quickly and it's kind of just making these weird ripples. So what I'm going to do is I'm going to change. So I had this time here go into the offset. And what that's doing is just offsetting our noise 3-dimensionally as we go through. So I'm just going to set a multiply constant. And this is going to allow me to be able to kind of scale this up or down. So right now, if we multiply it by 1, the time is going to be flowing at the same rate. So what we can do is we could multiply it by like 1/4 and see how that slows everything down and what that actually does. So now we're going to get a little bit more swirls and kind of this, stuff that's kind of all pushing through this a little bit more. So now it's not so ripply. It's kind of allowing it to flow a little bit more. I think I even went down a little lower than that when I was playing with it before. That's going to start to give it some more swirls and things like that. Now this is definitely blending together a lot more than I'd like for it to. So I think what we want to do here is change the frequency a bit. And I'm trying to remember which way is which. I'm going to say that if we do the frequency down, the noise is going to get bigger. If I'm remembering correctly, sure is. And that's gigantic. We don't want that. It's probably a little too big. So let's maybe go up a little bit with it. Something like that. I'm going to turn the roughness down a little bit too. Maybe turn the octaves down, just so we're really more pushing this around and not like trying to make these like crazy ripply things going on here. And then let's keep kind of just playing around with some of these attributes here and just see where we go. Yeah, so we're getting kind of some interesting swirls going on here. Maybe that's a little bit too big, but we can do maybe 7.5 and see where that goes. Now, like I said, the really nice thing here is that this is darn near real time. At least for me, it is. I mean, your mileage may vary. Last night I tried to find the VOP equivalent of times equals and plus equals in vex and failed. It's not multiply constant, is it? That might be the equivalent. It's a little different because times equals it is basically setting it to whatever you're. Yeah, I guess it's pretty similar. Yeah, it's very similar. Yeah, there's a multiply constant, there's an add constant. The only problem with that is, let me just see here. Let me type in constant. Yeah, so these are all constants that you can do. Oh, that's interesting. I didn't realize there was a multiply and add const. Oh, that's cool. I never seen that before. That's cool. You can do a pre-add, a multiplier, and a post-add. Kind of neat. So it's plus multiply. So it's add, multiply, add. It's kind of cool. So yeah, those are good to use, but the only problem is that that constant that you're multiplying it by isn't actually an input here. So that's something that's a little bit of a catch. If I was trying to do something like that, I would probably just I'd probably just do a straight up multiply and add in something that I could promote. That's what I'll do a lot of times. Like if I was going to do something that I really wanted to tweak at the top level, I would do like this. I'll just show you what that looks like. So if instead of this, we wanted to do a multiply like this, take the product out here, and then I'll middle click here and promote this parameter a lot of times. And that's going to make a parameter up a level. So like if I'm trying to do something, this is like another way that I'll do stuff, but like maybe here I'll do like time multiplier, right? And then up here I'll just say like mult time for the name of it. And then when I go up here, I actually have that time multiplier right here, so I can just adjust that at this level. That's what happens anytime you put down a parameter as well. But that's like, so if I did a parameter node, that would do almost the same thing. And in fact, I can double click this and it'll turn into a parameter. So there's a couple levels of complexity there, but this is a lot of times what I'll do if I needing to like have control over something that I'm maybe multiplying something by, scaling something, whatever in VOPs. So hopefully that makes some sense, but I don't know if there's like a one-to-one of the times equals, just because that's like maybe a lot of times you'll take an attribute that's already written and just do times equals and just spit it out. There's not really something like that because you're binding, at least that I know of. I haven't run across something that's exactly like that in VOPs. So that might be one of the things that aren't an exact one-to-one, but anyways, cool. So our time multiplier, I think I had at 0.1. So now we have that exposed up at this level. So that's kind of fun. Cool. You know what I'm going to do? Actually, I'm going to make a little bit more definition here just so we can, yeah, no problem, man. Of course. I'm just going to make a little bit more definition here so we can see this a little bit better. So let's just kind of give a little bit more negative space here, and maybe just a little bit more positive. So this is just making it basically more contrast in here so that we can see that maybe a little bit better. So cool. Actually I was thinking maybe the shape with this confinement, I believe that's going to help with some of these swirls if I'm not mistaken. So maybe we turn that on. No, that's looking for a field. Yeah, what is the name of that one? That is is there a vortex? Is that what it's called? It is called gas vortex confinement. I thought that's what it was. I think it's actually making that control field. Let me just check. And I don't think I turned that off. Fields. Nope. Oh, should have a confinement field. Oh, I guess there is a confinement field. Interesting. Well, what we could do is just try this, see if this works. See, when we do that merge, you get that purple as well. So you kind of know that that can be done that way as well. Not sure if that's doing anything. The other thing sometimes that you might want to do with this is simulation. Is maybe add just a touch of this viscosity. That'll just make sure it's kind of not maybe mushing together, but it's kind of staying a little bit more, normalized to the yeah, that's kind of cool. We're getting some swirls and things like that in there. It's nice. The viscosity just kind of keeps neighboring voxels to kind of all be flowing together. So anyways, you can kind of play around with these as much as you want. You can add turbulence in here. You can add like a gas turbulence here. That's the same kind of concept as what's happening in this shape here with this turbulence. So you can kind of tweak a ton of stuff here. Like if we did disturbance, that's actually going to break this simulation up and make it like almost like more noisy. Yeah, see, it kind of breaks up these fronts a little bit and causes there to be these like noisy little eddies where there's no density. So obviously, as you can see here, that there's mostly density here. So I'm actually surprised. I maybe need to tweak that a little bit more. Let me see here. I think something like this might be better, actually. Let's try that. Now, if I was going to, for example, up the, um, maybe give it a little bit more sub steps. I'll just try that. The more sub steps you add into this, the better it is going to, the better it's going to keep the shapes and kind of respect everything that's going on in there. It's going to, obviously allow it to have more smooth motion in the simulation, all that kind of stuff. Obviously, it's taking a little bit longer. We're down about half the speed that we were at before, which makes sense. We're adding a lot more substeps in. So yeah, I mean, these are all things that you can kind of determine. I mean, I'm not going to prescribe how to do this, but just to show you kind of some of the things that'll happen in here when you start to tweak some of these different settings. Here, this disturbance is going to add some, ripples into here. It's kind of interesting. We could keep that. That should show up in our simulation to some effect, because that is going to be affecting that velocity there. So really, anything that we do to the velocity in here is going to be seen when we take it to the next step with the particles. All right. So I think we're looking pretty good here. I don't think we need to go too crazy with this. Let me see here. Let me just see if there's anything else that I did before here that I really want to emulate. Let me just see what my settings were even on this. Oh, that's right. I didn't play with that flow rate. That's right. I did just about everything the exact same, which is fun because I was playing around with this, and actually this is a little higher than it was before. But anyways, so I tweaked this flow rate. Let's see the difference between that. So let's look at this first. Maybe what I'll do is I'll just hit a flip book real quick and we can kind of compare these against each other. Always like a good flip book. What's going on here? Where's my flip book? Hello? Here we go. Jeez. Took you long enough, flip book. The nice thing is obviously this is going to go pretty quick. So, and a lot of times, like if I was doing a bigger simulation, I'll do a lot shorter. I won't go all the way to 240 frames, for example. Like if I'm just playing around with something, like that's a lot, 10 seconds or whatever. So, all right, let's change this flow rate and remind myself what this does. So let's make a new thing here and we'll hit this here. If you don't know, in here, this little icon will give you a whole new flip book and then, or a new sequence, and you can then have sequences in here that you can flip between. Good. It does absolutely nothing, apparently. Cool. Good. I'm glad it does nothing. That's great. Well, good thing I set it to 2.5 in my last one. Man, we would have really missed out if we didn't. That's funny. Maybe I need to turn this up to get a difference. I don't know. Let's try that. Now if I do this, is going to overwrite the second flip book here. So. Oh. No. No difference still. Oh. Yes, it is. It's weird. Is it jumping back and forth? I can't tell. Must be what it's doing. Yeah. Yeah. There's so many little things and even the flip. I mean, don't even get me started. There's so many things in Houdini in general where you're like, somebody says something, you're like, oh God, that's really what that does? Holy crap. Okay. Yeah, actually that's looking pretty cool. That's got kind of a neat feel to it. I actually like that a little bit better than this one. This one feels a little bit more like stagnant in some of these areas, but this one has kind of this nice like rolling kind of thing going on in some of these. So yeah, what you can do here is you can also come up here to compare images, and then we can see the difference between the two. Um, so that's kind of nice as well. Which one's which? The left, this is the new one. This is the old one. Yeah, so there's a little bit, that's kind of interesting. Yeah, I like how some of that stuff is actually happening in there. There's actually some, I think that's more interesting. It's getting some interesting swirls going on and stuff. So I'm going to stick with that. That's cool. There's always something to learn here. But yeah, so this is cool. You can also change here. You can change this to be split. That's split horizontals. You can do split vertical here. That'll adjust where the vertical split is. You can do compare, which God for this, that's not helpful at all. You could do highlight differences, and then this turns into a thing where it's like actually like it's like a threshold of like how much the difference needs to be pixel value to see it or something like that. But yeah, these are better for maybe something like a particle sim where you can actually see things moving around one versus the other. In this, it's just a mush, so it looks like super trippy. But anyways, yeah, that's always a good one. And if you, I think if you have FFmpeg installed, it'll show this up in here, and that's a real quick way to make out an MP4, which is nice. I don't know if that's standard or not yet. I've lost track of so many. Who knows? But anyways, all right, cool. So that's good. And if you want new sequences, you hit this button here. That's always, so like now if I hit that, that'll make a new sequence the next time I run a flipbook. Okay, anyways, here we go. Let's go back here, and now let's do a sim. Actually, sorry, I'm gonna make a geo node for down here, and we'll say sim output. Oh, actually, you know what? Let's just do sim particles, because we're going to be basically going right into the particle sim. So let's do this. This is also going to be a sim node, so I'll just kind of put this over here. So let's jump in here. Let's do a dop.io. I always forget which one's which. Like it takes me like a few times to remember which one I want it to be. Okay, yeah, this. I think this is the right one. I can never remember. Gosh, you'd think I would have remembered it by now. Yes, this is the more fully featured one. .io, I think, because yeah, this one allows you to do some saving and things like that in here as well. This one is just so this has it packaged inside. So the other one, the .io or the .import fields, is like the basic one, and then this one has the saving and all that stuff built into it. So cool. All right, so what we can do here is we can just do pyrosim if we wanted to, but we're not going to need to load all these in here. So let's get rid of that. Actually, you know what? We could probably just come up here and do smoke, I bet. Yeah, that's fine. We're not going to use rest. We're not going to use CD. Those three will be fine. All right, so now let's point this to these different places. So we need our DOP network, which is going to be SimPyro. Our DOP node is going to be our smoke object. And that should be good. Now we've got our density, velocity, all that stuff coming in. Let's see. Let's do a VDB vector from scalar. I believe is the right one. They changed the name of that, but that's okay. So yeah, now we should have. That's weird. Oh, that's odd. Thought that's how that would work. Let's see. So what if we do pyro post process? I think that one has this stuff in it. Yeah, this is good. That should be good. And so let's just convert it to VDBs. We don't need to compute the minimum maximum values. So this will just kind of clean up our thing and just have a velocity field coming in there. Cool. Looks good. So that's just kind of simplifying our world a little bit here. And then what I'm going to do is an object merge, and we're actually going to bring in that original geometry up here, this grid geometry. So I'm just going to say a null, and we'll just say grid geo. And so we're actually going to be pushing around the points for that. So let's do this. We'll say get grid. I like those to be red because that's just the color I like them to be. And let's see, grid geo, accept that. So now we've got all of our grid in here. And let's just do an add. And we can use this, delete geometry, keep the points. That's good. Let me think here. Is there anything else we need to do on this before we start getting into that? I'm just trying to remember. I don't know if I did this step on this other one. We'll have to see why I did that. Yeah, that doesn't make any sense. Oh no, it does. It does. Okay, so well, we can play with that in a second. All right, so we got the add here. So let's just do a pop network. If you don't know the official thing here, the pop network is literally just a DOP network at this point, and it just sets up your pop objects inside. So we're going to put this into here because that's going to be our source. The first input is going to be our source. These are all of our points. And so we're going to go inside here. We're going to look at this source first input. And you can see here the emission type is scatter onto surfaces. Instead of that, let's do... Oh, in fact, we don't even really want that. We want it to be... I want it to be here, the initial geometry. So... Just let me double check that. Sorry. Just trying to remember so I don't... Yeah, that's fine. We can do that for sure. So I'll show you a little trick here with this. So we don't need this source first input. We don't actually need either of those. We're just going to use this pop object, and there's an initial geometry here. And this is just going to simplify things because we literally just want to pull all those points in, and that's it. Like we don't need to be doing anything frame to frame. So we're going to do a little expression here, which might look scary, but don't be alarmed. So we're going to use this one and say op input path. And op usually stands for some sort of operator. And if you're used, obviously have been in Houdini a little bit, you're used to SOPs and DOPs and all that stuff. Those are just saying dynamic operators, surface operators, things like that. So this is basically saying our operator input path, right? So what this usually is able to do is tell us what's coming into our node. And so in this case, we're going to do op input path. I'm going to do an open parentheses. This will give us some examples. And you can see here that in this case, say we wanted to find the path of the node connected to the first input, use op input path, parentheses, period, parentheses, comma, 0. So that's the first input. Second input is 1. So it's computer science world. So 0 is the first one, 1 is the second, so on and so forth. So it's a little weird, but hopefully you might be used to that with Vex and things like that. So, so what we're going to do is we're going to use a similar thing here. We're not going to use just one period, but we're going to use 2. So instead of this node's input, we're going to be looking at its parent's node's input. Hopefully I said that right in English. But so we're going to do 2 points, comma, 0, and then close the parentheses and then do this. So this should mean that and there it is. Boom, right like that. And if we middle click on this, it'll resolve to object/sim particles add 1. And that's what's up here. This is the add 1. So this is the path that it's looking at. So this connection is literally now just driving this expression here that's saying, hey, where are we looking for that input source? So instead of having a null there and pointing to it and everything like that, this is just an easy way to be able to say, hey, whatever's coming in here into the first input, use it. And so that's really helpful if you're using stuff like coming into like a DOP network, for example. Super, super helpful. Because then you can just, again, point this over to here. And we know that in this case, when we do something like an pop advect by volumes and do this, we could probably do this pre-solve, I think. Let's try that. So what we're going to be using, we could point to a specific SOP, but instead, if we do the same thing here, copy this, And just like in the documentation, it said, instead of 0, we want to look at the first input. And so now what this should resolve to is that pyro post process that's coming in there. We're looking at the field name of velocity. And so this is going to be, you could also, in some of these, set these here to the second context geometry. So multiple ways of doing everything in here. So this is going to be the exact same thing. And so let's start playing with that. We should see these starting to move. Yep, looking good, looking like we're moving. Now, are we getting any vertical movement here? No, we are not. So what we're seeing here is a different method than what we're going to ultimately use. And the reason for that is you'll start to see that these points are going to start leaving this grid. The reason for that is that this velocity is updating a force on those particles. So when you do an update force, what you're actually doing is kind of adding some velocity into it and using that to kind of push it in a certain direction. So in this case, everything's kind of bunching up and clustering and doing things like that. And that's not really what we're going for here. It certainly is a fine option for other things. Like if you want something to advect loosely based almost like in this case, you can see here that there's an air resistance. The more you set this, the higher you set this, the more it's going to adhere to this specific grid, right? So this now is going to follow that flow much, much more closely, but it's never going to follow it perfectly, So that's one thing that we're going to play around with here. So there's a couple different advection types. And what I'm going to do is have it update the position. So let's see if we can get this to work. And this should do what we were hoping for it to do. Because all it's going to do is take these velocities that we are putting in there and use that to change the position of these particles. So it's not actually injecting it's not injecting a velocity at in this situation. It's actually taking the velocity and just straight up moving the point, that vector that you have in your velocity field, and just saying, okay, this point is right here. This is where I'm looking up the velocity at this point. It says it's going this direction. All right, move it to there. And so this will keep it within that grid always. It's not going to come outside of that grid because there's no velocities outside of there to point it out that way. So if our velocity wasn't constrained to that grid, sure, it could go anywhere. You could use a pyrosim and have it kind of flow all around and do whatever. But in this case, because we're starting with a grid, it's not ever going to leave that. And you can see, again, this is incredibly quick. There's really very little calculation that's happening here. It's basically using this almost as like a SOP solver in a way, where it's basically, you could write this in a SOP solver and have it move, look up the velocity vector here, move it, look up the velocity vector, move it. But in this, it's like we already have nodes that are built for this. There's no real reason to overcomplicate it. So let's just look at this and see if there's any difference between these two pre and post solve. I don't think there will be at all, but let's just check just for fun. So I'm going to just do one here, let this flow around. It went so quick, I was thinking I was waiting for something still. I doubt we'll see any difference here, but we'll see. Maybe. Let me bring up that sequence list again, and I'm going to set this there. Oh, yeah, so this might be a good spot to use compare. So this is basically going to show us if there's any differences, and there's not because it's completely black. Your big question about update position. What kind of motion blur can you hope for from that advection type? So yeah, there isn't. So that's the interesting thing. There is no velocity being updated. You're right, but you can very easily retain that. You can recalculate that basically. There's probably a couple different ways you could do that, but one of the easiest ways. So just first of all, here this isn't showing anything, so we're getting zero difference between those two. So great. There's no difference there. Just a trail stop. Exactly. That's exactly the easiest way to do it. Because at this point here, we have just particles. I'm just going to set this to pop star just to make sure we're only getting the particles out. And then if we do something like a trail, Or actually, I've liked the point. What is it? I think it's point velocity. This is easy because literally the second you drop it down, it does that. It gives you those velocities. So yeah, so now at this point here, if we hit play, we're going to see all those nice velocities coming in here, kind of moving itself around and everything. Cool. So yeah, so now we've got velocities in here. And I mean, the time, there's no extra calculation or anything that needs to be done here. Obviously the more there's a couple different things here just to keep in mind too. The more detail you have in that original simulation, like the higher that resolution is, the more detail you're going to get in this part of it. And the settings are all going to, yeah, the point velocity is a great node. It's basically just all of that trail stop stuff, but with some other nice stuff like curl noise. Like you could add in curl noise to it if you wanted to. I mean, not that that's going to do us any good here, but you could do that. You can also add object from the motion of I think a transform of an object. So if like an object's moving around or something like that, you can add velocity from that. And I don't even know what conical noise is. What the heck is this? I've never even seen this before. Oh, I see. Oh, that's interesting. Gosh, yeah, I'm learning something too now. Look at that. That's fun. That's something. Something fun's happening there. So I think what they're saying with this is that it's basically creating noise in a direction based around a cone angle. So I use this a lot for like if I'm doing if I want velocity to go in a certain direction, but I want it to be randomized, that's what I'll use. So in this case, it's going up, and the cone angle might be something like, whatever. I'll make these longer so you can see them, but maybe it's like 10. And so they're only going to be 10 degrees in a cone that they can randomize within. And then if you change the direction, like say we had a little bit more in this angle here, you can see they're all now going in that direction. So I actually didn't even realize that was part of that. And I've used attribute randomize, attribute adjust, vector, those. So I actually didn't even realize this was in here. So yeah, we both learned something new today. But yeah, there's lots of cool things in here. And you can obviously just set a velocity here as well. You can calculate the speed of something, which is actually cool too, because obviously if you did that, and let's just go back over here, you can get, it's basically just doing the length of it quickly, which is nice as well, because sometimes you want those speed values for something. Anyways, it's a great node, point velocity. Yeah, we don't need to calculate speed. The other thing too, I'm going to do here. Yeah. Yes, there's lots of different things you could do with this. It's all sort of angular velocity. Oh yeah, it's everything. It's all the good stuff. I'm going to clean this up here. I'm going to just do an attribute delete because we don't need all these different attributes, because we're going to be doing copy to points, and it's going to need to calculate through all of those. So there's really no reason to. So let's just clean this up a little bit here. P velocity. Actually don't think there's really much else that we're going to need. Oh yeah, I'll do that down here because we actually, it doesn't matter actually. It's irrelevant. This is going to recalculate that V. Oh, I'm like, why are these? I see. These just ones aren't moving anywhere. I'm like, why are some of these not getting any motion in all these axes? But they are. I'm just not looking at the right ones. Cool. All right. So we got our points here. And so now from this, what we can start to do is think about copying these to points. And so the other thing that I did here was instead of just having it flat, I wanted it to be maybe a little bit more interesting looking and not just be this kind of flat geometry. So what I did was I just did I used the mountain stop, which is technically not the mountain stop anymore. It's the attribute noise with blah, blah, blah. it's using the normal of it, but actually these don't have normals, so let's add a normal to these. Let's add a point normal here. It's so weird. Okay, so instead, let's do an attribute adjust vector. This is actually the easier way of doing this now that I'm thinking of it. So instead, we're just going to do n. We're going to do a constant value of 1, like that. Now these should all have normals that are pointing up. They do. Great. And so now this will actually work. And so the cool thing about this is that it's going to literally just, since this is, this is basically just looking up its position and, moving it in kind of a, basically based on that, that normal, it's moving it up or down, and based on the amplitude and all this kind of stuff. So, we could make kind of a terrain from this, and this is obviously all adjustable after the fact, and we can make the amplitude bigger or smaller, however we want to do this, kind of tweak this, to our heart's content. We could use different noise types. We could make the fractal, more or less rough, probably less, so it doesn't look so bumpy and noisy. But here you can see that we're starting to get this flowing pattern over, some geometry like this. And what we could even do is add in, especially with this, we could use a little bit of animation, and we can have this be animating throughout, oh yeah, that's way, I forgot, that's the opposite. So pulse duration is basically saying how long is it taking for it to go through. It's kind of a loop, and every quarter of a second is quite a bit too much. So let's do 5. Nope, too little. Let's do 2. So you can see here we can kind of play around with this. Maybe 2.5 will be best. So now we have this kind of flowing geometry that's got some interesting stuff going on there. Maybe we set that to 0.5. Get some interesting flowing geometry here. And of course you can use all the different noise types. So you could do something like this, where you've got this crazy cellular kind of pattern going on, all sorts of different, everything's on the table with this. I mean, that's just wild looking. I mean, some sort of weird technology is going on there. I don't know. So you can make some interesting stuff with this, obviously. Yeah, so it's like a cool cellular kind of thing. Whatever to your heart's content. But the really nice thing, obviously, here is that we're not re-simming anything. This has all been cached and simmed and all that kind of stuff. So now we can kind of play and art direct this stuff too. So really, anything that's happening in the world of SOPs at this point is fair game. We don't have to really worry about anything because everything is now existing in here. And we could even add more points. We could jitter it. We could do all sorts of different stuff. So like if we did like a point replicate, something like this. I mean, I'm just kind of thinking off the cuff. That's too many. But let's just do something like this. 10 points per, and we'll make the uniform scale of 1, something like this. So now we've actually just, oh, that's way too big still. Let's do this. Nope. Let's kind of get it till we're like maybe just a little bit more loose, like that. Sure. Okay. We'll stick like that and do 20 maybe. And so now this is going to be a little bit randomy, messy thing, but there's going to be way more points in here and they're all scattered through it like that. So you could point replicate it like this. You could do something like a point jitter with it. That maybe you could almost do 2 things with it. You could do this, plus like a type jitter, and this is going to like randomize them as they're moving through these fields. So this is going to even like kind of noise them up some more, and you could do the seed where it's going by $t so it's like time based, and maybe multiply that times 0.1s, so it's like, oh, maybe that's too much. Sorry, it's probably freaking out. Yeah, I guess that won't work so well because it's updating the seed every time. That's not exactly going to work so well. But I'm just kind of thinking off the cuff here. So, you could do something like that, and it's going to kind of add this randomization into it. So, I mean, there's a million different things that you could do with this now because it's all been simmed. We're not pushing all of this stuff back through simulation constantly. So sometimes you get more control when you're not simulating something. You're not trying to simulate 10 million points or whatever. This in this case we have 62,000, and I ran this up to 1,000 by 1,000, and it was still pretty performative. So like if I just do that, for example, here, I'll do 500 for right now. So it still is going to be fairly performative. All that should flow pretty well. Our resolutions should all update here, and let's just come back over here and see what we get. Now you can see obviously our points are going to be quite a bit closer together. And yeah, I mean, this is running all of those sims at the same time. So this is running both that 2D pyro sim and the particle sim, kind of updating, solving all of this. And so, we're getting multiple levels of this. And so if you don't like the way that these flow lines are going there, you just go back to the pyro sim and kind of tweak that, because you'll see more or less a 1-to-1 between the two. So there's what that looks like. And if we come back over here and look at our pyro sim, those should be incredibly, incredibly close to each other as far as like the way that they're deforming. So if you're like, oh, okay, I see what's happening now here, and you can tweak the shape of that and get the points to be able to kind of follow along a little bit differently. So in these zero density areas, we're getting kind of this, a little bit more random looking situation, and here we're getting a little bit smoother. So, you can use that to your advantage, or tweak that however. The other thing too that actually might be changing something a little bit here is this disturbance might be freaking us out a little here. So if I turn that off, I wonder if that's going to lessen this noise in these areas here. In fact, it probably is, because that's adding a lot of noise in these kind of sections here. So the disturbance is going to add some velocity into those kind of empty spaces in your pyro sim. So that's where that noisiness is coming in here. So knowing that, you could come back in here and instead of 0.5, maybe you do 0.1, and that'll give you that little bit of noise in these areas without completely maybe breaking that up. So it's going to kind of give a little noise in that area, and the other part will be a little bit more smooth and flowing. So, knowing some of these things and kind of tweaking some of these different parameters and settings will allow you to kind of balance the two together. And obviously you could do some stuff in, you could just add velocity into a pop network as well. But really the benefit, I think, of doing it this way, and there's a million ways to do everything, but I think the benefit of doing it this way is that you get that really nicely confined pyro sim to start with, and then nothing's kind of flying off from your pop sim or anything like that. So that's just the reason I'm kind of doing it this way. I'm sure there's, like I said, there's a million ways to do anything. But all right, so we've got this going here. We've got our mountain, and this is all going to just flow and work, which is really nice. So that's going to be doing its thing there. Everything's flowing around and twirling and doing everything kind of that we wanted to do here. So then let's just let this run again. Actually, I'm going to turn the scale back down just so it can finish a little quicker. Let's do 250. Actually, let's do 350. Bet you that'll be good. A little more detail, little less time. Cool. So while that's going, so we want to copy points to this. So let's do a couple things here. Let's just do, I did a platonic and that kind of looked neat. So let's do that. Platonic solid. Set this to an icon. I could set it to whatever you want. Yeah, let's do a dodecahedron. Fun. That sounds great. Cool. And then from there, let's do a copy to points. That's going to be gigantic. Sure. So what we want to do there is... Oh, right. Our best bet there would probably be... there's a couple different ways we could do this, but I think what I'm going to do is take... that's going to freak out. So, I mean, if your computer's a little funny, it might not like doing that because that's going to be a big copy there. In fact, probably an icosahedron is going to be actually lighter for these scenes. So let's do that. All right. So what I'm going to do is do an align and a scatter and align here. And what this is going to do is add attributes to existing point cloud. That's what we want. And oops, does this go over here? I can never remember. Yep, that's what it needs to go into the second. So this is kind of weird. So this is the scatter surface, but if you're not using the scatter surface, it gives you this little angry thing and then lets you do it, and it's just fine. So I don't know. I don't know what the deal is with that. But this will control a bunch of different things at the same time. So first of all, we can change the radius of these really easily here. So we can adjust these way down. Yep. So let's go down with the radius on these. Cool. So let's do maybe 0.15. That should be good. And then we can do a minimum radius and adjust that down. So we could do it to be like 0.25. We could adjust the maximum radius up a little bit, or we could just adjust the overall scale up a little bit. So, you know, maybe we do 2.5 or no, 0.25. Yeah, maybe something like that. You know, maybe the smallest one is 5. I don't know. Maybe something like that. You know, obviously this is all very, like I said, art directable. It's all able to be adjusted and done whatever with. So let's just kind of move through this, and we'll see that this is going to start to flow, you know, through this particle kind of sim that's happened here. And, you know, it's making all these kind of shapes and swirls and all this kind of stuff. So the only thing I'm pretty sure that's happening here, and in fact, what I'm going to do instead is I'm just going to use a cube just to illustrate this a little better, because these aren't very directional, so it's a little hard to tell. So let's look at the cube. Sure enough, those are all pointed exactly in the same direction here. So unfortunately, we're looking at these all, and they're all being oriented in exactly the same direction. We want them to be randomized a bit. So what we can do here is do negative 180 and do positive 180 here. And that should update. Sure, make me a liar. I see. For some reason, after this, the normal gets set to 0. It's really odd. Oh, but now it's... That's weird. Huh. That's actually adjusting all of those orientations on their own. This one is not. So that's really odd. I wonder... That is really strange. Just make sure I'm not missing something here. Okay, maybe that's what we need. We don't need to recompute the normals, because that's basically just setting them to 0, and then there is no normal for this to rotate around. So what this should do, and now if we look at it again, it will have done that. Well, it did that. I don't know, that was a weird way of saying that, sorry. So this here allows us to randomly rotate around that axis, which is up in this case. So Oh, that's another thing I could have done. I could have changed it in here. Instead of using the normal direction or whatever, I could have just changed it there. Okay, whatever. So this will allow us to have these be randomized, but the yeah, it seems like that's going to work for the most part. Let's see here. Yeah, that's looking good. Yep, that looks like that's working for the most part. I was actually thinking that this wasn't going to, it was going to randomize, like it was going to re-randomize like every frame or something like that, but it's not. That's good. So what this is doing is setting an orient attribute, and that kind of overrides everything else from this align or copy to points, and it's the dominant way of aligning these objects here. So yeah, so now when we look at this, we'll see that these are all going to be flowing, doing their thing, moving around like that. So the one thing I'm a little interested in is I'm seeing some separation in some of these areas, and I kind of wanted it all to stay a little bit more even. Kind of wondering if that can find, because these where I was just kind of playing around with stuff. So I'm kind of wondering if this is freaking it out, because that's the only thing really different that I did here. Let's just check if that gas confinement is gonna help us. Yep. Yeah, that I don't know. The other thing is too, I did the other one like a much higher resolution when I was playing around with it. Um, so that's part of it as well. That you're going to see maybe a little bit more gaps when it's lower resolution. And again, tweaking the scale of the smoke and all that different stuff is gonna change a bunch. So any little adjustment that I might have made here is going to make a difference. So let's just come back over here and see if I can get this a little, maybe just a little closer. Pyro source. Just checking my values against each other here. Up a little. What? Oh yeah, don't need those on. Oh, that's interesting. I didn't actually normalize this to clamped. Okay. Check my pyro settings here. Double check that. Make sure I didn't do anything crazy here. It's really just this one node, so not a ton I can really be doing in here. Frequency, change this a little bit. Amplitude was 5. Actually, the max octaves was 8. Oh, interesting. I had no self-advection. That might be the big difference here. Cool. Maybe I accidentally hit that. Let's turn the disturbance off for right now. We'll just see what happens here. Just see what happens. Yeah, I think it's just one of those things where you're gonna have to, play around with it a little bit until you get the settings that you want. Now, in this case here, the reason that you're seeing this is because there's a little bit of you're going from a grid, right, and you're pushing it around and really swirling it and skewing it and things like that. So there's going to be a little bit of that. So honestly, the less that it's like really pushing that original pyro sim around, kind of the better in some cases. Actually, that's the other thing I wanted to look at. Okay, so I was mostly using the original velocity. So let me see there, because that was the only other thing was in here. Yes, so technically I had this at 0.9 in mine before. Let's see what that does. So I'm going to just kind of play back around with some of these things because I think I did like some of what was happening here. All right. Sorry, I'm just like trying to think through some of these things like that. I didn't want to have a ton because I actually, when I typed in as what I thought a small value was going to be, it ended up jumping by like a pretty good amount. So I was like, that seems like maybe too much. Yeah, I think this makes more sense. It's kind of pushing it a little bit more. It's not so swirly and noisy. And hopefully that'll kind of keep it a little bit more confined into its where it wants to be. So, all right, so let's do this and see what this is doing. That's kind of doing some interesting stuff. I don't know. You can kind of play with this stuff all day. That's the crazy thing is like these attributes, there's so many of them and it's like you can just tweak and play and do all this stuff, like so there's going to be a limit to kind of how far I can maybe push these things to give you a good, give you at least the right direction on where to go with them. And then from there, a lot of the art direction is kind of up to you, unfortunately, at that point. But, yeah, I think this is like basically back to where I had it before. Like I said, with mine, when I had done the previous thing that I was showing, the difference there was that it had what do you call it? It was 1,000 by 1,000 instead of 250 by 250. So yeah, that's really the big difference between what I was doing, what I did previously in this. So this is just a lot less detail in how many boxes and things like that. But even with this, I mean, it's not running, it's running at 10 frames a second, but it's still, it's copying a couple hundred, couple 100,000, I think, points. I don't know how many it is. 122,000 copies of this box, it's not too bad. You can also do the pack-in instance that can give you some, at least I think some viewport performance. Yeah. It gives you viewport performance. It won't change the speed at which it copies it, but I think it'll give you a little bit better viewport performance if you're running into that as an issue. Okay, so the other thing that I did, I'm gonna actually put this platonic back in here because I think that's maybe a little more interesting looking. The other thing that I did was adding the what do you call it? The color into this. Sorry, it's been a little bit of a long day. But okay, so what I'm going to do here is at this pop net, I actually want this to have an ID starting it. Now, a lot of times if you're sourcing things in it, it'll set an ID, but in this case, it's just literally taking in what we're putting. So here I'm just gonna I have an AE ID, which literally is a really nice node. It enumerates the points with ID. I think there might be an enumerate as well. Yep. So you could use this as well. This actually, I'll just change this out because it's the same, more or less the same thing. So this should enumerate, and I'll change the attribute to ID. Type is integer, and we'll change this to points, and there's my ID. So that is good. So that's kind of nice, gives us our ID, and then we put it into this, and then that makes sure that we keep all of our point IDs as we're moving through this whole craziness. And then from there, kind of at any point here we can do this, but I'm going to just do it, I guess, right here. So let's do a adjust color. And I'm going to make sure that we are doing this by... Oh, the accumulate solver. I haven't used that recently, so I can't answer that, to be honest. But yeah, I'll answer it now. Yeah, AE lib is great. Yeah, I don't think the accumulate's been. I haven't tried it, so it's interesting that it's not working. It probably is a Python thing. That makes a lot of sense if it is. Let's see. Remap attribute is what I want to do, and source attribute we will use ID. Let's double check that that's working. No, that's not right. What am I missing here? Sorry. My brain is a little tired right now, apparently. I'm having a hard time. Let's see what my color was here. Did I use attribute adjust color? Noise, color ramp. Ah, that's what I did. That's right. All right. So this, I did it a little differently. Whoops, wasn't thinking straight. So what I did was I did a color. So I did set initial, noise, color ramp. And so in this case here, it's going to keep the noise the whole time, right? The noise is never going to change, right? It's just going to kind of go up and down because it's taking it from the location basically. So it's not really changing it. Cool. I actually one-upped you there. But now that I'm thinking about it, ID probably isn't the easiest way to do that. So what I'm going to do instead, which is probably, it's fine. You can leave that there. But what I'm going to do is I'm just going to do the rest position. Just drop that in here. And the really nice thing is that this part will simulate like psycho fast. So if I just like jump this down here, it should basically just calculate all that really quickly. So I'm going to use this rest instead, and I'm going to keep that through the chain here. Let's see. Let that pass through. We've got our rest position, and then I'm going to drive this by rest. Nope, not pressed. Rest. There we go. So that's obviously taking the rest position, and it's going to use that to drive the noise through it. And now that's going to do the pretty colors and do all that fun stuff. So again, the really neat thing about this is that this is all art directable after the fact. So if you did something like this and wanted to paint something on there, you certainly could just as easily. You could do all sorts of different things with this. I mean, obviously you can adjust the color ramp. I think I just used something like, I don't even know. I think I did Twilight, or I don't know what I did. Something like that, or, whatever. You could, there's all these fun different colors that you can use that are pre-built in here. Obviously you can build your own. Here's a whitewater one. Cool. So yeah, so now this texture is going to go through there, and this should all flow through here into our objects. And so there is kind of the the colors flowing through here as we go. And so that you can change that anytime too. So like if you're like, oh, I don't like the element size of this, I want it way bigger or way smaller. This just is being done on the rest position. So it's actually being done in this location, and then as it moves, it's keeping that reference into that, look up into that noise basically. So yeah, you can play around with this all you want. There's tons of stuff you can do here. You can play with the offset. I mean, sky's the limit. Heck, you could even have this animating. I mean, this is probably gonna look just totally wild, but say you did something like, I don't know, instead of one, maybe we do two. Then you've got animating noise through your particles as it goes. So I mean, it's all on the table at this point. But okay, so that is one thing. Now I just want to try to play around with something else real quick here before I kind of wrap this up, because really this is basically where I had left that scene in the what do you call it, in the Discord channel. Now, if you wanted to do any, like, make sure these aren't colliding, you could always put a pop grains in here, I believe, and that should keep these from colliding, I think. Not 100% sure, but I think it will. Yeah, it's hard to say because they're not really colliding anyways, I don't think. I saw some overlapping before, so I wasn't sure if that was the case, but oh, you know what I could do? I could just put this over here too in the pre-solve, and then that way they'll be slightly decoupled. It'll be advecting and not trying to do those all at the same time. So this way, before the solve, it'll do that. So, anyways, the grain, yeah, grains should do that. Now with the position advection, yeah, that's a good point. It might, yeah. I think you're right. I think you're right about that. About the particle or the position advection. Yeah, that's going to really kind of overwrite that. So, you could again. What did I just do? I don't even know where I went there. I like dove into something real weird. You could instead do some sort of a. Yeah, yep. It's kind of like that. Yeah, but I think what you could do is do some sort of a. You might be able to do some sort of a relaxation after the fact, and kind of push these apart a little bit. Let's see. Let's see if we get down here somewhere. Not sure. Not sure if this will work, but we'll see. Just get super angry. How about that? Yeah, it's at a point radius of 1. That was stupid. Ooh, that was fun. Angry, angry. There we go. All right, too big, too big. Yep. Yeah, I know. I know you're not happy. Don't do point relax. Just in case you're wondering, don't do it. Let me be the one to show you what not to do. All right, manual. There we go. All right, so let's do this one, and let's do this like point. See if that does anything reasonable for us. Yeah, it's not great. All right. Well, I figured I'd give it a shot. Anyways, all right, don't use point relax, don't touch it. Bad juju. Um but yeah, definitely you're right. The point position thing, when you move that, is definitely going to make a big difference. Yeah, that certainly would be an interesting I'm just really glad that hopefully you're not following too closely with what I'm doing. If you are following along, I'll make the mistakes, and hopefully you can avoid them. Like I think I've said it before, but I got really spoiled by having a computer that had, I mean, a decent amount of RAM at my studio job I was at before, and so like, yeah, I'm sorry. Just hit escape, spam the escape key. My bad. Um, but like having like 256 gigs of RAM, it takes a while before that like totally is gone. But if you're like on 32, like I have a laptop now for like work stuff. Yeah, I mean, that's the thing is there's like Jack, I think you're right. There's a million different ways to kind of get around stuff in Houdini, and it really is there's so many different ways to do it. So it's yeah, I mean, flip is certainly a totally fine way of doing it. I mean, I don't think there's anything wrong with that. I just kind of wanted to show this from like a standpoint of like art directability maybe might be more strong here than in flip. Like being able to change the scale of everything that's happening in here and knowing kind of what you're getting each step of the way through it is a little bit cleaner um than maybe doing something in flip. Um yeah, it's tough. Flip is I think a little less controllable in a lot of ways because there's so many calculations that are happening in there. With Pyro, you can kind of turn down the number of different variables and just kind of take it one at a time and get these kind of linear. So, anyways, yeah, but Flip is certainly a fine way. I think that's how they said they did it anyway. So, I mean, yeah, you're the solution that or the one thing that you guys had posted in the Discord channel. But all right, so I'm gonna do one more thing here and see if I can get this to work. It might. We'll see. So what I want to do is I want to set this. I want to scale this. So let's scale it. Okay. So what I'm going to do is I'm going to take this grid when it comes out, and I'm going to scale it down. Let's do a match. Let's see if I can project this onto another geometry using UVs, because I've done that before with something else, and it's been a little while, so I might have totally forgotten how to do it, but let's hope I can remember. All right, so let's scale this to fit, first of all. So this is going to be in a 1-to-1 grid, and I'm going to take the offset and justify it by 0.5, 0.5. So now this should just be in the positive 0-to-1 quadrant. It is. Great. So let's think about this as this is our this is our UV grid of coordinates of points, basically, or coordinates. So this is all happening now in a 0-to-1 kind of little bound here. And I did this. Hi Zach, how's it going, man? Good to see you. Glad to have you on the stream. So I've done this before with doing knitting for like geometry and stuff like that. We did a hat thing for New Era at one point, and getting all the loops and stuff like that attached to the hat was like a winter hat. So you really needed to see, we were super macro on it, so you needed to see all the little things. So this is kind of a thing you can use for any type of geometry to kind of copy it over to another UV geometry. So let's do this. Let's do match size. Let me just hit a null here. And I'm going to say out. I don't know what to name that, but I'll try that for right now. And then let's take something like should be simple enough. Oh, actually, you know what? Isn't there let's say there's a sphere that's like a labs one. Yeah, and it's actually going to do kind of that. Yep, that's exactly what I wanted, because now I have UVs on it. Although they're repeating. Yeah, I don't love that, actually. Let's just do it regular. So this I'm just totally winging. I don't know how if this will work well or not, but we'll see. All right, so we got a sphere. I'm just gonna do an auto UV, labs auto UV, just real quick. Nothing fancy here. Great. Doesn't really matter where those are. Let's just turn this grain tolerance. Sure. It doesn't really matter. I just want it to be kind of on there somehow. Have some UVs. Great. It's a mess, but whatever. So, let me think here. I want to do a. Oh man, now my brain's totally gonna blank on this, even though I've done it quite a few times. This was something I'd gotten from an entanglement tutorial at one point, and now I'm gonna totally forget. Okay, so I want to do this. Do this. And let's see here. So what we want to get is X, Y, Z, not distance. I think it's prim UV. Okay. So I'm going to want to use this prim UV, and this is going to take the attribute. It's going to interpolate the value of an attribute at a certain parametric position. Nope. I actually want to do that UV sample. I think that's what I want to do. Sorry. Give you a little bread trail to follow there. Okay, so I think what we're going to get here is all right, so let's try this. Let's just see what we get here. I'm just gonna do via test, see what this spits out. I'll probably should just do this offline, but and see if I can show what this is. But I don't know. I had this idea, and now it's getting late, and my brain's probably dying slowly. UV sample. All right. So what did it say? So we wanted to set the geometry, the string attribute name, the UV attribute name, and let me just see if there's a good example in here so I can see what they're saying. Yeah, I think it. Yep. So, okay. So let me do this. This should be UV sample. I'm going to do one. String attribute is going to be P. This is going to be at UV. This last one. Can't remember what it was. UV sample. Oh, yeah. So it's just UV attribute name. Okay. Oh, cool. That's where my mouse is. If you can't tell, silly power tools. Okay, I guess that's right. So this will be UV, and then this will be at UV. I guess. I don't know why it wants it to be exactly like that, but let's try it. See what it does. Do we get anything? Am I getting something? I don't know what it is, but it's something. Oh, right. This doesn't have UV coordinate. So what if we do at P here? That do it? Ah, it's almost doing it. There's our sphere. It's just not. It's just not doing it though. Yep, that's what I just did. Yeah. Yep. Yeah, that's the same thing I just typed in. Um they're missing something here. Hmm. Let me think about that offline. I have my old file somewhere. So the yeah, I've definitely done this before, and I'm just blanking on it right now. I was like, oh, we should totally do this, but it's 10:30 and my brain's starting to shut off. Let's just not do that here. Sorry, this was an extra thing. I'm gonna do that offline and figure out exactly how to do that. But what you can do is something kind of like here. Let me pull up. See if I can pull up something that's an example of that. Yeah. So this is from my just from a project that I had done a while ago. But like this here is all made with like this whole hat is made with that process basically. The entanglement tutorial that it was from shoot. Let me look. I can put it in chat here. Tutorials. Yeah, sure. Give it a shot. I mean, I'd be interested to see. I'm sure you can figure it out. It's not there. I mean, those guys are awesome. They explain everything very very well. Where is it? Where is it? I'll just look at it on the stream instead of next to the stream like a dope. Oh yeah, it's an old one. It's an old one. It's got like a hacky sack looking thing on it. Let's see where it is. Yep, we're getting closer. Back in the days when everything was free on Intagma. I mean, I totally there it is. Knitting and 3D building a UV deformer. This is the one. Going into chat. Oh, okay. Yeah. That makes. There's the link. Um, okay, that makes some interesting sense. Let me see here. So this just needs to have. Yeah, let me try that. Well, I guess I'm trying to understand why the. Oh, maybe it should be a point attribute too. That actually could be part of it. Let me just check. V. Nope. And up in a wrangle earlier in the chain. I'm not sure where that would go because this doesn't have a UV, so this doesn't matter. This one does have a UV, but it's already set to 0. Yeah, I'm not sure why. Theo, I'm not sure why setting it to 0 earlier. Is that working for you? Setting it to 0 earlier? Or are you just suggesting that? Curious. Riveting content by me waiting for an answer. Man. Ah, yeah. Suggesting it. Yeah, I think I think it's just there's more to that step. I think I'm like way oversimplifying that to the point of like absurdity. I have a feeling that there's like a really complicated step there that I'm just like, yeah, it's just this one thing and it should be like 20 and I'm just trying to be fancy. Um yeah, they flatten the geo into two UV 2D coordinate exactly. Yep. So what I did in that hat example was um which I don't know if they do a I don't know if they do any cutting of the geometry based on the shape of the UV space. I'm not sure if they do that or not, but like cutting out the actual geometry, I had to do that because the hat didn't have geometry everywhere. So like I actually had to like boolean out the outside of the geometry that wasn't there. I did a few different things. I mean, that would be God, I'd like to go back and redo that because I did that probably five years ago, and I probably did it really stupidly. Like when I think about it, it's just insane. Like, so the thing that's very interesting about what we had to do here, and it might not be particular. Did I put that somewhere else? Where'd it go? What might not be super obvious about it is I don't, so with that hat. Oh, you know what? Actually, I should probably. Oh yeah. Let me just go right to. This is the company I used to work for, Dpost. They're awesome. They're in Buffalo. Let's see, commercial. Somewhere. Must be missing it. Or they didn't put it up here. Oh, that's a bummer. Show it. Dpost. Just so annoying. Vimeo. I don't know what they did to Vimeo, but it is a mess. It does not work the way you want it to anymore. Okay, we'll just go to Vimeo. Let's see if we can find them. No, can't even search anymore. Watch something. Hello. Man, what a disaster. Can't even find it. Let me see if I might actually have that file somewhere. Give me 1 second. I think it's a really fun explanation of what this is. So let me look it up here. Mm, Guys, this is riveting content. I'm sorry. Huh. I'm super confused because I made my demo reel. I updated it recently, so I don't know where it went. Oh man, I must be losing my mind. Hmm. Maybe I don't have it. I don't even know. Just feel like I've lost my mind. Anyways, the thing that was really interesting about what we did for that hat, if I could ever find it somewhere, but the thing that was really interesting is we you actually had to change the colors of those threads. So we had to have all the threads set inside of it. It was insane. Like there was literally like we were like painting out like a pixel grid of like the names of teams and the hat and stuff like that. It was crazy. Like to do a breakdown of it would be like hours and hours and hours. But yeah, it was that was a pretty cool thing. But I used almost exactly that thing, just with some cutting and stuff added in there, and some deforming. And then I took it from there and added like instead of it just being one thread, I twisted like 8 threads around it or something like that, because really that's what I guess yarn is. There's like multiple threads that are twisted around and stuff like that. So we had to learn a bunch about knitting actually, or yeah, I guess it's knitting. Yeah. Because we needed to know how to have those loops actually look like they were the right way. And so we learned that if you flipped them around, you actually get the separate, like if you mirror them, you get those separate like ribbed patterns and stuff like that. So we had to do a lot of like research with it and stuff like that. So it's a pretty fun project. But we use that completely where you flatten it down, you actually save the deformation in the point when you flatten it, and then once you project it back onto the geometry, you can kind of re-thicken it by adding that deformation attribute back into it. So it's a super smart way of doing it. And obviously, I wasn't going to reinvent the wheel, so I used that method and then went from there. So it's turned out pretty cool. So, anyways, it's 10:45 and my brain's shutting off, and I'm just sitting here looking up files while you guys are watching me. So, please create a grid and set 1 to 1, add all UV to it. Yeah, I'm trying to think if that would, because really, yeah, I mean, really, what you're doing when you P vertex 0 UV vertex number. Okay, all right, following. I see. Gotcha. Cool. I don't think I'm gonna try that right now, just because like I'm gonna miss something with the match size and stuff. Yeah. Um, let me find let me refresh my brain on that one, because I'm gonna probably have to just, yeah, it's getting late, and I wanted to get this for you guys to take a look at and everything like that. So hopefully the stuff that we did as far as like all this actual stuff worked, like hopefully that was cool and felt, um, feels helpful and all that kind of stuff. Yeah, maybe. I'm trying to. Yeah, I guess maybe it does. I was thinking that it just used the point position to look it up, because really, yeah, for another time. Because really, what I was thinking that it we're doing here is basically looking up the position that the point should go to. Basically, like, hey, these points are now, the position of these points are now representative of UVs, basically, because it's in that 0 to 1, um, space. And so you could kind of just, they basically are UV position. The positions kind of are the UVs because it's in that coordinate space. Um, so yeah, I'm not sure. I'll look it up. It's probably something really dumb and simple. I think it's only like one or two wrangles, maybe, now that I'm thinking of it. But hey, how's it going? I can't. Your name is green on my thing. Sir Sir dies a lot. I'm guessing that's your gamer tag. Hopefully, I don't think you can do that in real life very much, but yeah, welcome. Thanks for joining me. I'm actually going to be ending the stream, but hopefully, you can go back and watch some more of it. But glad to have you with us, and yeah, hopefully you got something out of this stream. So yeah, any other questions about this setup? Just like while we're here, I mean, without the UV thing that I made a total side tangent into. Any other questions about like how this is working and how, we've got this flowing? Yeah, there's always something to pick up. Yeah, oh yeah, for sure. That's Houdini. Cool, cool. I'm glad that this at least feels like it's pointing you in the direction that some of that other stuff was going. And again, there's a million different ways to do everything. Like Jack was saying, BFECC advection. Uh, oh, cool. I've been most focusing on writing code to automate asset creation. Cool. Oh, that's awesome. Um, Asset creation in just regular Houdini and Solaris and with USD. Like, any specifics there with that, or just making a bunch of assets with parameterized assets. Kind of curious. That's interesting. The rest of my day, if anyone else wants to know, was basically trying to figure out how the merge lop specifically works in Solaris, because it works completely differently, and it was a fun dive into slight insanity. Oh, oh, cool! Wow, that's fun. That's really cool. I'd love to see that. You can always. Oops, it's not PG stuff. Hello, hello. Sorry. I just knocked my face down. I've used it mostly to do textures and vertex lighting. Cool. Well, that's really awesome. I'd love to see, yeah, please, if you're on the Discord, if you go to Houdini Hangout, there's an invite to the Discord channel there. So feel free to post something in there, if you want to share that and get people's feedback or whatever. I mean, that would be awesome. There's like a work in progress thing in there, a whole bunch of other stuff that you can use to kind of post things. So yeah, Discord. I don't, does that do something? I'm sorry. I'm in my mid 30s, so I don't understand all the Twitch stuff. So maybe that exclamation point Discord does something. I don't know. But yeah, Discord. Um, anyways, hopefully, if you're on it, cool, awesome. That sounds great. Oh, I see Coco. Maybe that's you. I don't know. Oh, I probably should have set something up that be a command. That's, if there's a way to do that, somebody can DM me on Discord or something and let me know. But I don't know how to do that. So sorry. This. I'm. Yeah, I've been around for. I feel like I'm getting too old for this stuff. The guys, I used to work with some guys that were in their like earlier 20s at my last job, and I would just basically say to them, "You guys make me feel infinitely old every day." a link in my Put a link in my Twitch cards. That's a thing too, apparently. Okay, I'll have to look into that. I don't know what any of that means. like I said, I'm going to be 37 this year, so I'm getting to the point where a lot of this stuff is just like feels weird to me. It doesn't make a ton of sense, but maybe I'm just being ridiculous. Anyways, all right. You're getting tired of me now, so like the link to your tip. Oh yeah, that's right. I forgot I set that up. I set that up like months ago. I don't know if that does anything. You can have a link to the Discord as well. Oh, cool. Yeah, that's a great idea. I hadn't even thought about putting that in my Twitch. I was like, I don't know what the protocol is for that. I wouldn't want it to be too overly accessible, so like bots are spamming it or something. But yeah, that's a great point. That's a good one. Okay, cool. Well, anyways, guys, I'm gonna sign off. But yeah, thank you guys so much for joining. Again, like I was talking about, there's a Discord if you guys want to jump on there and chat. I try to be pretty active on there. I'm on the computer all the time, so. Oh, cool. You posted reduced. Great. Awesome. Very cool. Well, great chatting with everybody. I'm glad this was helpful. And yeah, please reach out. There's a help channel if you run into anything on any of the stuff that you've seen on my streams and stuff like that. And you're like, hey, this doesn't make any sense to me or whatever. Drop it in there. We can have chats about whatever. Happy to help. So yeah, it was great to get to chat with everybody. Sorry that last night didn't work. Glad we could do it tonight. And yeah, I'll talk to you guys later. Have a good one. Peace.